Okay, today we're taking a look at network configuration in OSP 16. I recently saw a question on Reddit and I've been asked some questions just personally, so I thought I would make a video and address network configuration in OSP 16, or if you're using upstream, then that is the train version of OpenStack. So network configuration can be really confusing because it's really difficult for someone like me to document that process. I could completely document my home network and that would be in great detail, but it would only be relevant to me. It wouldn't be useful for 90% of the people reading it. So we have to be really generalist when we kind of document that kind of process, because it depends on how your networks are configured, what your security policies are, how many routers are in the environment, are you using spine and leaf networking, what's your topology look like. So TripleO is really flexible and it will facilitate basically any network configuration that you can dream up, but that means that it is fairly complex to achieve those kind of things. So I hope that this video will kind of simplify that. So what we'll look at is how you configure that in your heat template, how that is then turned into something that Ansible can consume and apply on the Overcloud nodes, and what that looks like on the Overcloud nodes. And we'll go over some best practices and some things, and I'll give you some tips that will hopefully make your life a bit easier in this whole process. So in one of the videos I made recently, we looked at TripleO Quick Start, and I'll link that video for anyone who hasn't seen it. This environment has been deployed with infrared. I haven't made a video on that yet, but I will leave a link to the documentation for infrared so that you can deploy your own environment if you like. I just find that infrared is a little bit better for deploying Red Hat OpenStack platform environments compared to TripleO environments. So in this environment, we can see we have an overcloud deploy.sh script. And in this overcloud deploy sh script, we can see we have this file here called network environment YAML. Now remember, these names are completely arbitrary, they don't matter. The main thing that matters is the ordering, and a file like this, for example, that doesn't actually exist, it's a Ginger 2 version if it's coming from the user share OpenStack TripleO heat templates. It might be a Ginger 2 version that doesn't exist yet, but it will exist when you run the overcloud deployments. Just be careful with that. In this case, we want to look at this network environment file. So we'll open that one up. And we can see down the bottom here, we have this resource registry. And down here, we're mapping files to heat software configurations. So we're going to look specifically at our controller, and we can see that it's referring to a file called controller.yaml in the 3nix VLANs directory. So this path is relative to the location of the network environment.yaml file. So if we just copy that, we exit. So we can see that was in home stack vert network. So we will delete back to here and we'll just paste in that. And now this is our network configuration file. This is what they look like in train and OSP 16. And that does change for TripleO. If you've watched my video on that in TripleO, this is a different process, which is why I figured it was worth its own video. So here we can see we define a bunch of heat parameters just like in any heat template, but if we go down to the network config section, which is here, just get to the top of it. So here in this parameter section, so anything in network config is what's going to be written to our Overcloud nodes in a JSON file. So you can see this first one, for example, we're going to map interface nic1 to use our control plane network. So this is the network down here under addresses. We can see it's using control plane IP, control plane subnet CIDR. And we're giving it some routes that are specific to the control plane, so control plane default route. And we're going to use that as the default route for all traffic on our controller nodes. And we also tell it about the EC2 metadata endpoint. So this is all delimited by spaces. It's all under this dictionary here, so anything in line with that is for our nic1 and for the control plane. Then we move down into our next section, which is the OVS bridge that we're going to call BR isolated. On that bridge we have interface nic2, so the physical interface that will be mapped to nic2, and I'll show you how to figure out that mapping in just a minute. And on that bridge we're going to have VLANs. We're going to have internal API, the storage network, the tenant network will be on that one as well. And then finally we're going to have this last one, which is again going to be type OVS bridge that we can see here. And that bridge name, this will by default be BREX, which is the external bridge that we use by default. We're not going to use DHCP for it, we're just going to give it an IP address from the external IP subnet. We're going to configure a route on there, and we're going to add in nic3 to that bridge. So on the controller node, if we do OVS via CTL show, we'll have BR isolated, that'll have our second interface in it, and BRX, which will have our external network with the nic3 in that one. So looking at Openvswitch, we can see there that we have BRX, BR isolated, we have our ENS5 in BRX, and in BR isolated we have ENS4 with all of our VLANs. So when you run your Overcloud deploy, we take this file and we turn it into a format that it can be consumed by Ansible in. So that gets downloaded by default in OSP16 to this directory. So var lib mistral overcloud, that's where all of the playbooks will be downloaded to. And then specifically we were looking at the controller, so it'll be under the controller directory. And if we just have a look at the files we have there, we can see we have this network config file. So if we cat that one, we can see here, this is the format that gets written to. So we turn it into a JSON format, and then we write it out to etc os.nic-config config.json, and that'll be on the actual Overcloud node itself. So we go to that Overcloud node, which is this one, and we just JQ that file so we can get it in some easier to read JSON format, and I'm going to pipe it to VI so that we can go through it. So we can see here that it starts with network config, and then we have all the information about our control plane interface. We can see that these fields have now been populated, where we have the default route being via 24.1, which is the director node. We have the information for the metadata EC2 endpoint. We have the IP address and the subnet mask up here, which we saw in control plane IP subnet and the subnet CIDR. And we see the DNS servers are being populated. Moving down to the next one, we can see that we have NIC2. We can see that we have the IP addresses now that have been populated for the various VLANs that were on that device. And we can see it's been added to BR isolated bridge. And finally, we have NIC3. It's been added to BRX, and it's been given a IP address on the external network with the default route of 10.0.0.1. So this gets applied with OS nic-config. So if you've never seen OS nic-config before, basically what it looks like is OS nic-config-c os nic-config config.json v. So Ansible will just run this. This will go and configure those nodes based on the information in that file. And we can see that it does some mappings here. So we can see NIC3 is mapped to ENS5, NIC2 to ENS4, and NIC1 to ENS3. So I think it's pretty important to maintain that NIC1, NIC2, NIC3 addressing. You could just change it back in your actual nic-config file back here. Instead of having NIC1, NIC2, NIC3, you could go through and replace them with ENS3, ENS4, ENS5, whatever your environment might be. And that might work initially. Say you do an Overcloud deployment with 50 Dell R740 nodes, and that works great because they all have the same interface names. But what if Cisco has a great sale on UCSs next month, and you want to get some UCSs for your environment? Well, they're almost certainly not going to be called the same thing. They might be ENP20S0, whatever it might be. So the problem then would be, now you need to create a different role and apply a different nic-config to those new nodes. So the benefit of using NIC1, NIC2, NIC3 is that these are mapped using the OS nic-config mapping. So you can customize that to your needs, and you could, for example, create a mapping just for those Cisco UCSs that would tell it what NIC1, NIC2, NIC3 map to. And you can see what those mappings are back on this node. If we do OS nic-config-I, so this will show the mapping. So you can see NIC2 is mapped to ENS4, NIC3 to ENS5, NIC1 to ENS3. And we do have documentation on customizing these NIC mappings as well, so that you could apply that specifically to some nodes and you could map those interfaces however you want that works for you. So the other question I've been asked in this is, we've got all these networks like tenant network, internal API, storage, etc., etc. What's actually happening on those networks? What is mapped to those networks? So it's a pretty good question, and the answer to that question is in our heat templates. So if we go user share, user share, OpenStack AAA heat templates, network service netmap.j2.yaml, we can see down here we have this service netmap defaults. And in this, we can see we have all the different services that we would expect in our OpenStack environment, like for example, our Keystone. So Keystone, you can see here, Keystone API network, Keystone public API network, and we can see what they map to. So we can see that the admin API network maps to the control plane network, and the public API network maps to our internal API and our control plane network. So that's where you could find these services running, and you would expect to be able to reach those networks. Now, if you wanted to move them to your external network, then you could just change that here, put it on the external network. So instead of storage management, for example, you would just replace that with external network, or whatever the name might be of your custom network in your network data.yaml file. So those names will match the networks that are found here. So you can see they're matching on the name lower. So if you had a custom composable network that you wanted to map services on, you would do that in that service netmap file, and you can override that as well. So it's just a heap parameter. So you can override the service netmap using this parameter, this heap parameter, and you can set it however you want, whatever works for you in your environment. But this gives you an example of what that would look like and how you could just replace internal API, for example, with whatever network that you wanted to create. And if you're trying to troubleshoot specific networks, then this is the place to go to look and see, hey, which network should that be on? Which network should I be able to reach that from? Can I reach it from that network? So that is all in this directory here. So the last thing to note is how we map the provider network. So by default, we create a network mapping for a network that we call data center, and that maps to the physical network called BRX. So that's defined using the Neutron Bridge Mapping. So if we can see we have this bridge mapping here in some of our test scenarios, but basically we use this argument, this heap parameter, to map BRX to data center, and that is by default. So when you create a provider network, you would do provider physical network equal to data center, and that will map it to BRX. So any VMs that are created using that network will have their interfaces plugged to BRX. And you would use that typically for a network that has your floating IPs, for example. So you would do OpenStack network create, for example, and you would use this argument here, this provider physical network, as data center. And that would mean that the network is mapped to BRX. So you do OpenStack network create, provider physical network data center, whatever other arguments you have, call it provider network, create some floating IPs on there. All those are going to route via BRX on the nodes. And you can override that. So you could map, like we've got BR isolated in our environment, we could map that to something else. We could create a mapping called tenant::BR isolated. And then if we did provide a physical network tenant, we would be putting VMs on that BR isolated bridge. So hopefully that addresses the concerns I saw on Reddit and some of the questions that I've been asked. I hope that helps to kind of make sense of what is arguably a very complicated process. But it's complicated to give you the flexibility to do what you need to do in your environment. So I hope that helps. I'll have some documentation links, some links to the AAA Quick Start video if you want to deploy some labs and start to play around with it. And if you have any questions, I'm happy to address them. Chuck them in the comments. I'm pretty active on Reddit. If you ask questions there, I will probably see them and respond to you.